back 8th graders, we're going to do 5.2 example 2. I hope I don't confuse the mess out of you, so I apologize in advance if I do. That is not my intention. I'm going to show you another application for the substitution that we've been learning in example 1. And I like the example 1 a bunch. I use it very frequently, and in certain situations, substitution is really the best option. And I want to show you another way to do it. Notice again, we have our system here. We have 4y minus 5x is equal to 9, and we have x minus 4y equals 11. Now, substitution using the distributive property, what that entails is that first, in one equation, so you're going to have to pick one of the 2 equations, solve for a variable. Now, I'm not going to make life harder on myself. I'm not going to make this a very, very complicated thing. And so when I make that decision, I look at both equations and I target the one equation that has a variable with a 1 in front of it. Now notice, there he is. That x and the x minus 4y equals 11, that x has a 1 in front of it. Now the reason why I'm targeting that is because once I move the y over, I don't have to divide either side of the equation by that coefficient, because anything divided by 1 is itself. So that's really an ideal variable to choose, is one that does not have any other number in front of it other than an understood 1. Okay, so that's what I'm going to do first. I'm going to solve for this variable that has a 1 in front of it. I'm going to solve for x in the second equation. So that means I'm going to add 4y to each side. And now I've created x equals 11 plus 4y. And this is another name for x. Now, I've already used this equation, x minus 4y equals 11. I'm not going to use it again, okay? At least not momentarily. When I use my substitution, I'm going to bring the other equation down, okay? Now, it's not a solvable equation because I have 2 different variables in it. But what if I had the same variable? Could I solve it then? The answer is, oh yes, I definitely could. Let me show you what this looks like. First step I would tell you is if you see any subtraction, go ahead and change that to addition so you can clearly see what the sign of the number is. I want you to see that 5 is actually -5. That's why I rewrote it as addition. Now what you're going to do is you're going to, I'll write that as a step, rewrite subtraction as addition. That will be fine. Okay. And then third step, we're going to substitute. And I'm just going to leave it at that. It's kind of wordy, I think, to write it out. But what I'm going to do is I'm going to take this quantity that I solved for and I'm going to rename x. X has a new name. I've already discovered it. It's 11 plus 4y. I'm going to take 11 plus 4y and I'm going to plug it in right here where the x is. So I don't have an x anymore. I have the quantity 11 plus 4y, which is, in fact, another name for x. So I put it in parentheses because there's 2 terms here. It's a distributive situation. So I do need to solve first by distributing. So -5 times 11 is -55. And then -5 plus or times 4y is -20y. All right. Now, I'm not ready quite yet to start moving things around. You notice I have y's on the same side of the equal sign? Well, that means I can combine them. They're on the same side, and I can put them together. So what is 4y plus -20y? And hopefully you said -16y. Okay, looking great. Now keep going. We're going to solve and we're going to add 55 to each side because we're really trying to figure out what y is equal to. And now I have -16y is equal to, looks like 64. And then divide each side by -16. And you will get that y equals -4. Okay? So we found one part of the answer, but we need the other part. We need to know what x is. So pick one of those original equations. This one looks easier to me, and I'm going to plug in what I know and solve for x. I know that y is -4. So y minus 4 times 4, that's y minus -16, which is really y plus 16. And then subtract 16. I'm sorry, I think I changed the variable on you. X plus 16. Subtract 16 from each side, and x equals -5. So remember, just because you solve a number first doesn't mean it comes first in the point, okay? So the point of intersection, the x is -5, and the y is -4. And there's your point of intersection right there. I will be very honest with you, this is not my favorite method for solving this. So if you don't like it, I don't blame you, okay, at all. It might just behoove you to, if you're just really finding yourself not liking it, not understanding it, then tomorrow or the next day we'll be learning another strategy, and you may actually like that strategy better for this type of situation. All right, let me show you B, just because I need to. And you notice that y is the only variable up there that is doesn't have a coefficient other than 1. That's what we want to target. We want to solve for y. So let's add 2x to each side, and we'll get y equals 2x plus 8. Okay, so now we have another name for y. And what we want to do is we want to take that quantity and plug it in right there, create a distributive situation. So now we've got 3x plus 2 times 2x plus 8 is equal to 9. That's what we have going on here. So we just renamed the y. We substituted in another quantity in place of y. So it's still technically substitution. And then we just need to distribute, add like terms on the same side, and then solve for that variable. So I'm taking away 16 from each side, and I have 7x equals -7. Divide each side by 7, and we've got x equals -1. So we're halfway there. We're not quite done with that. We need to pick one of the equations to plug into. I like that top one, -2x plus y equals 8. I like when they don't have as many coefficients. That's usually what I target. And then we'll plug in -1 for the x, and then we'll solve for the y. So we have 2 plus y equals 8. We'll take away 2 from each side, and y is 6. And so our point of intersection, remember, x is -1, y is 6. There's our point of intersection. So if you don't like this, please don't feel bad. I don't either. It's not my favorite at all. I think I like example 2 even less than graphing, if you can believe that. And I really don't like graphing that much. So, okay, bring your questions to class tomorrow.